All right, let's start then. Okay. So first, we're going to start off with databases today. So databases store some kind of data, right? So what is this data, first of all? So can someone tell me in the chat box, what is data? Yes, what is data according to you? Data is anything that contains stats, okay? Data is information, okay? Information, okay? Any info that can be recorded, set of info. Okay, so in computing, data is information that has been translated into form that is efficient for movement or processing. Wonderful. Okay, great. So data could be anything. Okay, data could be anything. Your shopping bill is data. The images that you store is data. Okay, the things that you see around, that could be data as well. The thing that you see on your screen, that could be data as well, right? So data could be anything. For example, some characters like A, B, C, D, all this could be data as well, right? This A could be data, this B could be data, this C could be data, this D could be data as well. Okay. Now, it only matters in what context we are using this, right? For example, this A, B, C, D, it is just alphabet for now. But if I say these are the grades, okay, A grade, B grade, C grade, D grade, E grade, and F grade. So that gives you some sort of information. So it all depends on what context we are using this things, right? These notations. Similarly, you have, let's say you are storing the data about your customers and you're storing the gender. So you can write gender as M and F. So this M might represent male, this F might represent female. You can also use 0 as an encoded value for male and 1 as an encoded value for female, right? So this could be data as well. So data could be anything that you see around. It is just in what context we are using it. Okay. So data is nothing but data is facts and statistics. You can say raw facts and statistics collected together for reference or analysis. If you just Google it, you'll find this. So in computing, what is computing? Anyone, can you tell me what is computing? What do we mean by computing? Riaz, just check your internet connection. Everyone is able to hear me? Everyone else? Okay, great. So what is computing? What do we mean by computing? Computer operating process. Correct, Paras. Okay. So in computer operating processes, or in computing for short, data is information that has been translated into a form that is efficient for movement or processing. So we need to process a lot of data to get this in some sort of analysis, to do some sort of analysis, or to apply some algorithms, right? So yes, computing is any function by computer. Now, in order to do this efficient movement and processing of data, the data should be stored in a proper format as well, right? So we need to store this data as well. And data should be stored in proper format. Now, if you see in your system, everyone is owning a system, right? You might have a PC or a laptop. Now, in a PC or a laptop, you will see that you store the data. How do you store the data? You have some file system, you name them, name this file, right? So you have n number of folders. Similarly, in Google Drives, you create folders and then you store the data, right? So here, this is your file system. We call it as file system. We are storing the data in these files. For example, this file might contain some images. This file can contain some videos, right? Some music and some PDF files or PPTs this folder might contain. So we need to store this data. And basically, how do we store this data? We store this data in form of files, right? So prior to this database management systems, even organizations used to store the data in this file-based system, just like we store our data in our system. Okay, but there was a problem with this approach. For example, now what we do is we develop this web application and all. So if you consider this IRCTC, it has a web application or an mobile application. So now we follow this server and client architecture. What do you mean by server and client architecture? So you have centralized server, right? We have a centralized server and you can have n number of clients. So client 1, you might have client 2, you might have client 3, okay? Then you might have client 4. So this was our traditional file systems where we used to store the data in form of files in different folders. Now then we move to this web application or mobile application, and this mobile application or web application follows this centralized server-based client and server architecture. So using this file-based system in this client and server architecture was very difficult. It was not efficient. Okay, why it was not efficient, we'll see that. And we'll see what is the problem with this traditional file-based systems. Okay, so the one way to keep information on a computer is to store it in permanent files, right? So file-based system are earlier attempt to computerize the manual filing system. Just like we have folders, so you create a folder for with your name or someone's name or something like movies, music, or some name that you give, right? But there was a problem. There were some disadvantages of this file-based approach. So what are those disadvantages? There was data redundancy. The data was not isolated. The integrity of data was not, or the consistency of data was not there. There were some security problems. And multiple user cannot access this concurrently. Okay, there was a problem. Now, let's see why this was a problem. Okay, so I told you that we moved to this server and client-based architecture. Okay, so we have servers, we have clients, right? So here, let's say you have stored your data in a system, and you have stored around 1 or let's say 25 KB of data, or let's say GB of data, not KB. Okay. So this particular folder, we have stored 5 GB of data. and some client, okay, some client 1 or client 2 want to access that particular data. Okay, let's say this client 2 wants to access this data. So this client 2, what it will do is, first it has to download all the files, all this folder itself. It has to access this folder itself. So in that case, what I will require is, I will require the attributes first of all to access this particular file. What I will need? I will need the attributes of this file. What will be these attributes? These attributes will be the name of the file, right? Then in which folder it is present. Then I will also need in which drive it is present. So I will require all this address of this particular file where it is actually present. So you see this C slash slash slash, and then you have my drive something, right? Then you have some folder. So you'll need all these attributes where this file is actually located. So that was a problem. Okay. Now, once you get this attributes, after getting this attribute, let's say somehow, what you will have to do is you have to actually download all the content of this file in this particular client system, this client system C2. So this 25 GB of data unnecessarily, it will get, you have to download this. So this client C2 will download it, and then it can access the information, whatever the data is stored in that. So that was also a problem. Why that was a problem? Because to download this 25 GB of data on client system every time, it will require some memory, and the download is going to slow down our speed, right? So the execution speed will be very slow. So it used to make it very slow, and it requires a lot of memory as well. So that was a problem. What was the problem? That it was not efficient, and there was high consumption of memory, because first I have to download this, then I can go and access the particular information that I wanted. Okay. Also, in file-based system, what used to happen is, if you have created multiple folders or files over the time, the data used to get redundant. Okay, there was a data redundancy. Why there was data redundancy? Because two files can store the same thing. I can store the same information in these two files, right? In these two files, I can store the same information. And even if you give the same name, sometimes it gives you warning that the file exists with the same name. But if I change the name of the file, but if I keep all the content same inside of that file, there won't be any problem, right? So it used to get redundant. We were storing redundant data. So that was also a problem. One more thing is, there was problem with the security as well. What is security problem? So once I downloaded this data, I can access all the data that is present inside this particular folder, right? No one is going to protect me from that, because I have downloaded it on my client system. I can easily access whatever inside it, whatever I have inside. Now, if you see this organization data, there are different use cases of this data. Not everyone has access to all the information, should have access to all the information, right? For example, your school data set. So some information student might have to get access to. Some information your teachers or faculty should have access to. Some information might only be present with your principals or higher management, right? So everyone should not have the same access to the data. There should be some sort of I mean hierarchy. But if I download this data set in my system, I can access all the data. But in database management system, what you can do, you can set this views as well, different views. So different people will have different access to the data. So a student will have only the information that is required for you as a student to view. If you are a teacher, you will only have access to the data which a teacher is required to see. And if you are a principal, you will have access to maybe almost all the data, right? But in file-based system, we don't have this security as well. Okay. There was also a problem with the concurrent access of the data. For example, if client 2 is getting access to this data, is using this particular folder, this file, now this client 1 cannot do any operation on this particular folder. Okay. What kind of operation do we do? You can do the read, write, and so on, right? So read, write. For example, you are having two clients. So two clients can do the read operation. So client 1 can read the file, client 2 can also read the file. But if client 1 is reading the file, client 2 cannot write in that file. Okay. If client 1 is writing in the file, client 2 cannot read the file. Similarly, two clients cannot write at the same time. It might lead to data redundancy. But in database management systems, you have all this constant. Okay. You have some constant that you can set on your database, and you will have this concurrent access. Okay. So this was the problem with our traditional file-based systems. All right. So again, data isolation. So often with an organization, files and application are created by different programmers from various departments over long period of time. So it keeps on changing and data might get redundant. Okay, integrity problem. So problem with data integrity is another disadvantage of using a file-based system. Right? So data values must satisfy certain consistency constraints that are specified in the application programs. What is this integrity? Okay, what do you mean by this integrity? Let's say you are selling some products. Okay, so you know what products you are selling. Let's say you are just selling two products. That is, you're selling Android phone. Okay, so we are selling Android phones and iPhones. Android and iPhone. So some people might enter the data as Android. Some people might just put A for it. Some people might just put I for it. So your data is not consistent, right? Your data is not consistent. Sometimes you're entering this as Android, iPhone phone, right? Sometimes you're just entering A for Android, I for Android. Because the different clients are going to access this data. So that was a problem as well. There was no data integrity. And as I told you, there was security problem, right? So if you have downloaded the data, you can access almost all the information that is stored in that particular file. And we don't have, we have this concurrency access. So it allows multiple users to access the same record without affecting transaction processing. Okay, a file-based system must manage or prevent concurrency by the application program. So after this database, traditional file-based system, the organization, they came to know that this might lead to all these problems. They moved towards this database approach. Okay. So database technologies plays an important role in most areas where computers are used, including business, education, and medicine, and a lot of other industry as well. You'll see they will be using this database management systems to store, to manage, to update, to query their databases, to store their data. Okay. So in DBMS, a data is stored in form of a structured table, and DBMS makes sure that it you have the security of your data. You can provide different views of your data to different hierarchical levels. Okay. And you can set some constraint on your data that will reduce your data redundancy and integrity problem. Okay. And when you're writing your query, you don't have to actually download all the data like we were doing it in the file-based system. You just have to write the query to get fetch that particular information. Not everything is going to be downloaded. You'll just get a view of what you need to know. Okay. So what is the meaning of this DBMS? Anyone, can you tell me what is the full form of this DBMS? Okay. Database management system, database management system. All right. So yes, it is database management system. So it says database management system. So what is a database? Yes, what is a database? Depends on data. No, it does not depends on data. Set of all the data. Okay. Collection of information. Okay. It is memory where many information are stored. All right. So a database is nothing but a database is just an organized collection of data. Okay. So database is nothing, it is just a organized collection of data. Okay. Let's take one example. Let's take one example. For example, your library systems or your banks, they have the data, they need to store the data about their customers, right? So we need to store the data about the customers. So what you have to store is, you will have to store customer ID, account number, customer name, right? Balance amount, and the address, and there are a lot of information that you will have to store, right? So customer ID, account number, customer name, balance amount. Okay. So balance amount and the address of the customer, right? So this is our account number. All this information has to be stored. Also, you need to store the information about their day-to-day transaction as well, right? So we need to store the data about their day-to-day transaction as well. How much they have debited, how much they have the credit, right? So every time we'll have this transaction details as well. So you'll have to store their transaction details of all this customer, right? So you're going to store all this transaction details. What will be this transaction detail? You'll have account number, right? Transaction date and time, the amount of transaction debited or credited, right? Then you'll have some transaction ID. So you have to give some transaction ID, right? And on what platform you have done the transaction. So all this information has to be stored as well. For example, one customer can have more than one transactions. Customer one can do 3 transactions in a day. We can do 4 transactions in a day, right? So I have to store all this information. Also, I have to store the bank information details as well. What is that bank information detail? I might have to store the branch code, branch code, branch ID, employees details, right? Who is manager, and all this thing. So not just one table, I'll have to create n number of tables and store this data. So a database is just an organized collection of all this information. Okay, a database is just an organized collection of all this information. And a database management system, okay, database management system, it is a software that is used to manage these databases. Okay, so data, it is an organized collection of your data. Database, it is an organized collection of data. Database management system are the software that is used to manage. What do we mean by manage? To create, to store, to query, to update, to delete the information, the data from this database. Okay, so just a second, let me just clear this. Paras, from next session, maybe you'll get the options as well. Okay, so this is just your overview session. We are not actually going into this actual content of the session. We'll start it from the next week because there are some students who are still enrolling and they want to continue start the session from next week. So that's why. Okay, everybody uses a database in some way. For example, we also use the database to store some sort of information. For example, your phone. In phone, you have a database where you store the name and the numbers, right? Similarly, if you create an Excel sheet, that is also a kind of database on. You're storing some information, right? So the best way to store data is using database management software, because the softwares, what they do is they are more efficient. Because when you if you think as an organization, as a bank, let's say, they will have million of transactions in just one day. Now this data, I cannot store it in simple Excel files. That's not possible. Excel is not that efficient. So I will need a software which I can use to manage, create this kind of databases, and also to manage them. Because sometimes I'll have to update, delete, right? And query the database. So these softwares and tools allows you to store, manipulate, and retrieve data in variety of different ways. Now there are different kind of databases, as we have different kind of data, right? So we had already seen the meaning of data. The meaning of data, data is nothing but factual information such as measures or statistics about objects and concepts. So we use data for discussion or as part of calculation. Data can be a person, a place, an event, an action, or any one of a number of things. So data could be anything. Okay. Now there are different kind of databases. So the most popular database, which has been there since a very long time, is relational database. So relational databases have been around since the 1970s. Okay, the data is stored in multiple related tables. Within the tables, data is stored in rows and columns. So RDBMS, in short, or Relational Database Management System, are the program that allows you to create, update, administer a relational database. And SQL is the language that we use for retrieving, creating, updating, and deleting, or in short, to interact with this RDBMS databases. Okay, let's understand in more detail what is this, what do we mean by RDBMS. Okay, so we can see that we are having some sort of relation. Okay, we are saying relational databases. So we are saying relation. Now in database relational databases, the data is stored in form of table. Okay, in form of a table. So it has some rows and it has some columns. So I'll just explain this in Excel. That will make more sense. Let me just move to Excel. Just give me a second. Right, it's hanged. Okay. So in database, we store the information in form of rows and columns. For example, let's take this example of bank again. So you'll have customer ID. Bank is storing customer ID, the account number. Okay. And bank will store the address of the customer, the balance amount, and all this information, right? So account number, address, balance amount, and all this thing. Let's say we have stored this information. So let's say the customer ID is 1, 2, 3, 4 something. Account number is 6, 7, 8, 4, 5, 6 something. Address, let's just give Mumbai, and balance amount as 5,000. Then we might have customer ID 4566, the account number something, city is, let's say, Chennai. Okay, and balance amount is 10,000. Then you'll have some other customers as well, and you'll have to store this information. Okay, so this is our one table. What is this? This is our one table. You can name this table. Let's say this table is our customer details. So what is this? This is our customer details. Right. Now you will see certain terminologies that will be used. So this table name, this table is also known as relation. Okay, so this table name is also known as, or table is also known as relation in databases. Okay, so a relation is nothing, it's just a table. Okay, now this rows, for example, this is the record of one customer. The customer ID is 1234, account number something, address is Mumbai, and the balance amount of this customer is 5,000. Right? So the rows are also known as tuples. So people also call them as tuple. So you'll see all this terminologies. So this is your tuple. These columns, customer ID, account, address, balance. These are the columns, and columns are also known as attributes. Okay, so these columns are also known as attributes. Okay, right. So you'll see this terminologies. Now in databases, you won't see just one table being stored. And there is also a reason why we call it as relational databases to this tables. So this is my one table, customer details. I want to also store the information about their transactions. So I want this transaction details as well. Now, from my bank, only those customer can do the transactions who are my customer. Right? If you're not my customer, you cannot do the transaction with my bank. You won't have the credit card of my bank, right? Or the debit card of my bank. So in this case, what you will do is you will have to store certain information about the transactions. For example, the customer account number. So the account number from which you are doing the transaction. Then the transaction date, when you did this transaction, right? Or transaction time, transaction ID. So you need transaction ID. And also you will need transaction amount. Is it debited? Is it credited? So if it is debited, you can put minus symbol. If it is credited, you can use plus symbol. So anything will do. So here, the account number could be any of this two only. It should not be any other number, any other account number, because if I do that, that will tell me that my data is not properly stored, or there is no integrity in my data. Okay, because only my customer should be able to perform the transaction. If I'm not having some account number over here, let's say XYZ 777777, this is not my customer, so I cannot store this. I can only store the information about my customers. So here, let's say this particular account number is doing some transaction, right? And the transaction date, let's say it is Jan 12. Okay. Transaction time, it is 10 a.m. Okay. So this was transaction account, transaction date, time, transaction ID. Let's say this is your transaction ID, which is 887979 something transaction ID. Then you have a amount number, right? So here the amount could be, let's say you have debited, so you have transferred 2000 to someone, so minus 2000. So what I need to do is I need to make a relationship between these two tables. Why I need to make this relationship between these two tables? Because I need to update this balance now, right? These two information I have stored into two different tables, and there should be some sort of relationship between these two tables, so that when there is a debit of this amount should get reflected in the balance amount of the people. And here it should be stored as not 5,000 anymore, but it should be stored as 3000 because you have been debited of 2000. And how we are going to link these two tables? So we are going to link these two tables based on this account number. So for this particular account number 678456, there is a debit of 2000. So I want to update this balance amount as well. Okay. So we can store this data in form of relation. We create different tables. We make relationship between them. We create relation between these two tables, 3 tables, 4 tables. It could be n number of tables. And we perform all these operations. Okay. So our database management systems, RDBMS systems, lets us do all this sort of thing on our database. We can store the data into different tables. We can establish the relationship between them. And also it reduces the redundancy of our data. Okay. It also maintains the integrity of data. So this is our relational database system. And to create this kind of databases, to also to update, delete, or to add new records, we need some sort of language to do that. Okay. So SQL is the language that you should use. That is structured query language. This language, we use it to interact, that is to create, to update, to delete the instances or the records in our databases, relational databases. Okay, so we'll talk about databases again when we move forward in the course. So this was just an overview. Let me just go back to the slides. Okay. Right. So as I told you, relational databases has been around since very long time. So since 1970s. And these data are stored into multiple related tables. Okay. Within the tables, data is stored in rows and columns. Relational database management system is the program that allows us to create, update, administer a relational database. And SQL is the most common language that is used for reading, creating, updating, deleting this records in the databases. Okay. There are also some databases, we call them as NoSQL databases. So in SQL databases, we store the related information in form of organized rows and columns, in form of tables, we can say, right? But some information cannot be stored in form of a table. Can you tell me what information cannot be stored in form of tables? What data cannot be stored in form of tables? Videos, okay, audio, images, right, text. All this thing cannot be stored in form of a table. If I'm storing some sort of employee information, some sort of bank customer information, schools information, that could be stored in form of tables, right? But I cannot store an image in form of a table. I cannot store video in form of a table. Correct? I cannot store the textual data. So most of the data which is present on internet, it is just text data, right? I cannot store them in form of a table because it has some rows and columns, some attributes it must have. So we have something known as NoSQL database. Okay, NoSQL means not only SQL. Okay, it does not mean that it is you're not going to use SQL. It means not only SQL, NoSQL. So NoSQL is a broad category that includes any database that does not use SQL as its primary data access language. Okay, so you have different NoSQL databases. You have Apache, Cassandra, you have MongoDB, CouchDB, and Couchbase, which can store the data which are not present in form of tables or in form of relations. So in these databases, the data is stored in form of a key and value pairs. It might be present in form of graphs, okay, or in hierarchical documents as well, or column family. There are also cloud databases. Okay, so cloud database refers to any database that is designed to run in the cloud. Okay, what is the cloud? Anyone can tell me what is cloud? Is it something that we see in the sky? So you just turn your head up and you can see your cloud. So what is cloud? You have this Microsoft, Google, right? And you also have AWS. They provide some cloud systems, right? Cloud services, server-based data stored remotely. Okay. So cloud is nothing but a centralized location for remote data storage. Okay. So these are cloud systems are nothing but these are just the systems which is given to you virtually. So you have virtual access to the systems. Okay. So you don't have to actually maintain all the system. It is done by all this cloud service providers. Right. So there are different cloud-based databases as well. So cloud-based database refers to database that is designed to run in the cloud, like AWS, your this Google Cloud, Microsoft Azure services. Okay, so Microsoft Azure SQL database, they provide it for your Microsoft Azure cloud. So okay, you have Amazon Relational Database Services, you have Oracle Autonomous Databases. Okay, so we have cloud databases, and the data is stored in key and value pairs, so key value databases. And mostly you'll see this Amazon DynamoDB, MongoDB, they store this data into key and value pairs. Okay, so one of the simplest types of SQL databases is key value database. Save data as a group of key value pairs. For example, if you're storing some information, what you have is you have some sort of key and value. For example, the marks. So you will create a key that will be marks, and with this key you will have the values associated with it. Okay, for example, the marks. So let's say 78 and so on. Then you might have some locations, then you might have some other information, and in this case the length of this information could be anything. For example, you might have just one location, so you can have just Chennai. Okay, you might have some other information like student your school's names. Okay, so the data is stored in a form of key and values in this kind of databases. Okay, so we have time series databases. So a time series database is optimized for time step data. Okay, for example, your temperature. So your temperature is time series data. Okay, your stocks. So stocks are also time series databases. So we have spatial databases that are optimized for this timestamp data. Okay, so we have Druid, ExtremeDB, InfluxDB that can store this time series data. Okay. Now, the main question is why collecting this data is so important. Okay. So in order to understand that, we need to understand the process of what is how we apply a machine learning. Okay. Or what is the project, if you're working on a project, what will be your project cycle as a data scientist or as a machine learning engineer? What's going to be your project cycle, or what are the different stages that we involve in machine learning projects? So first of all, whenever you go for machine learning projects, the first thing you should define is the problem statement. Okay, problem statement. What is it that you are trying to solve? Okay, it might be anything. You might want to predict the price of second-hand bikes, the price of your houses. You want to predict who is going to win the match, right? So you define your problem statement first of all. For example, here, predict the price of used bikes. So what we want to do, we want to design a system, we want to develop an algorithm or make a model that will predict us the price of used bikes. Okay. Now, in order to solve this problem, what do I need? What all information about the bike you will need? Hey, you are going to buy a new, not new or used bike. So what all features you are going to look for? What all data you are going to look for? Okay. So you look at the model, right? The age of the bike, kilometer driven. Okay, all this information, kilometer driven. What is the mileage of the bike, right? What is the power of the bike, or how many cc's? Right? Kilometer driven, age of the bike, model of the bike, mileage, power, engine power, right? And all this information. Who is the manufacturer? Similarly, you are going to look for the owner. Is it first owner? Is it the second owner? Is it the third owner? And so on. So you need to collect all this information first of all, right? We need to collect all this information. The model, the age of the bike, the kilometer driven, the mileage, the power, manufacturer, owner, then the engine type. Also, you will require the information about seat type. You will require the information about the types of wheels that has been used, right? Count and the insurance of the bike, correct, right? And also there are a lot of other information that you will need. So defining a problem is the very first step. Then you are going to collect this information. So you need to decide what information do you need in order to make a model that will predict the prices of this used cars or used bikes. So here I have just listed down some of them, right? We have just listed down the some of the attributes of the bikes that we'll be looking into. That is the model, the age of the bike, kilometer driven, mileage, power, manufacturer, owner, is it self-start or not? Okay, what kind of braking system is used? What is the engine type? What is the engine power? What is the wheel type? Right? So you will require all this information. And then you will also require how much you have sold it this bike for previously. Okay, what was the maximum price that you got for that particular bike? So I'll require this price information as well. And not just one or two, I will require maybe tens of thousands of information about the bikes, the used bike that we have sold, so that we can train a model and this model can do its prediction. So we need to collect this data. So sometimes this data, if you see, might be present in your databases. Sometimes this data might not be present in your databases, right? So in that case, what you will have to do is you will have to come up with a method to collect this data first of all. Once you have collected the data of 10,000 previously sold used bikes that you have sold, now you can use this data to train your machine learning algorithm, to train your model. And now if a new bike comes in, you can easily predict it. So first of all, I need to collect the data. Defining a problem statement is the first thing. After that, I need to collect the data, right? So there are different ways of collecting the data based on your project. So data sometimes might be present in database. Sometimes the data might not be present in database. So it might be present over internet. So you'll have to do web scraping that time. So you'll have to download the data from web. Okay. Sometimes you will have to do some sort of survey to collect the data. Sometimes you might have to conduct interviews to collect this data. So there are different approaches to collect this data. Okay, so we'll see that. So collecting data allows you to store and analyze information about your existing and potential customers. So collecting this information can also save your company money by building a database of customers for future marketing and retargeting efforts. So whoever this customer is coming to you to resell his bike or her bike, if you are storing that data in your database, that information you can use to train your model, to make your machine learning algorithm, to train your machine learning algorithms. And you can use that data to build this kind of models which will predict the price of used cars. We'll come to web scraping. Don't worry about that. Web scraping is just downloading the data from internet. So you can write a Python program to do that. That is your web scraping. Okay. So what are the different ways of collecting this data? So close-ended surveys and quizzes, open-ended surveys and questionnaires. So close-ended surveys and quizzes are nothing but you just go to your friends or the close relatives and collect the data. You ask them, take the surveys and quizzes. Open-ended surveys and questionnaires, it's just when you put it online, anyone could take the surveys and questionnaires and you collect that information, and after that you analyze that. Okay, you can also do one-on-one interviews with different people and store that information. Okay, and you have some focused groups. So you have identify some group of people where you go and collect this information or do your surveys and quizzes. And sometimes you will just observe and write down this data. So you'll just do a direct observation. Okay, so these are the different ways of collecting the data. Okay, so why is data important for machine learning? So machine learning data analysis uses algorithms to continuously improve itself over time. But quality data is necessary for this model to operate efficiently. Now, a machine learning model, a ML model, okay, requires a lot of data to learn from it. And the data should be proper, it should be consistent, it should not be redundant, right? So we need to make sure the integrity of our data, that whatever we are putting in this ML model is proper, is not redundant, it is, the integrity of data is maintained, it is consistent, so that our model can learn from it. And the more data that you put in this machine learning algorithms, the better the result you will get. So the better the learning this model will have. So ML models require a lot of data to train them. And once it has been trained, you can use it for the prediction. Okay. So there are different stages of this machine learning project. That is, first, as I told you, you define your problem statement. Okay. So you define the problem statement. Then you will have to collect the data. Once you have collected data, you have to clean and analyze the data as well to make sure your data is proper, is consistent. Okay, so cleaning and analysis of data, it takes a lot of time. Almost 60 to 70% of your time is going to be in cleaning and analyzing this data, in exploring your data, because we want to supply a good quality of data to our machine learning model. Otherwise, you put garbage in your model, the garbage will come out. So garbage in and garbage out. Your model in that case will be less efficient. So before giving this data to our model, we need to clean. What do you mean by cleaning? You need to remove some unwanted variables. You need to take care of some missing values. You need to find out the inconsistency in your data set and remove that. And also you can identify some patterns in your data that will be useful for these models. Okay. So after doing this cleaning and analyzing the data, then you do model building. You go for model building. Okay. Not every time in just first try itself, this model, whatever you have built, gives you the correct output. This model learns from itself. Okay. It is learning from the mistakes it is making. So you need to make sure that the model that you have made, it is efficient, it is effective, it is giving you an accurate result. So we need to check, evaluate our models as well. Okay. We need to evaluate our model, how well it is working in real time. For example, you are building this, let's say, same problem, and the actual price should be 8,000, but your model is predicting that the price should be 15,000. So if you're going to sell that bike for 15,000, the customer will not be happy, right? Because the actual valuation of that price is 8,000. Sometimes your bike might be for 8,000, but your model has predicted that it should go on. You should sell it for only 1,000 rupees. Again, you're going to make loss in that case. So we need to make sure that our model is working properly. So we evaluate our model, and there are different ways of evaluating your models that you will see when you reach to this machine learning. Okay. And if your model is doing giving you almost good accuracy, 80-90% accuracy, in that case, you're good with that. You can deploy your models. But if you want to again improve the accuracy of your model, you will again have to go back, collect some other information, like some other specification of the bike that might be useful, or you might have missed something when analyzing and cleaning the data. So again, you go clean the data properly, see if you have missed anything, or try to find out some patterns that might be useful and use them. Again, you build your model, evaluate it, and see if the performance has improved or not. So this is not just one time you're going to collect the data and clean the data and do the model building and then deploy it. No, it is a cycle. You need to keep on improving your model. Okay, you need to check whether your model is doing right job or not, correct prediction or not. If it is not doing, go back again, repeat this process, include some other variables, do some cleaning process, try to find out some patterns by analyzing the data, and then again build the model and see whether it has improved or not. Okay, so these are the steps that are involved in your machine learning projects. Great. So data sets are a collection of instances that all share a common attribute. So machine learning models will generally contain a few different data set, each used to fulfill various roles in the system. Okay. Now, there are different types of data when it comes to machine learning. For example, when you are storing some information, when you're creating and storing the data about students, let's say, or the bank employees, the data will be of different kind. Some data will be in character form, in textual form. Some data will be numeric form, right? For example, the name of the employees. These are all our characters. The address of the employee, again a character value. The gender of the employee, again a text data, right? Then the balance amount, that is going to be numeric value. Okay. So there are different kind of data that a machine learning algorithm should handle. Now, when it comes to machine learning processes, machine learning models are nothing but these are just mathematical models. Okay. These are nothing, just mathematical formulas that are running behind these models, this machine learning algorithms. And I can only do mathematics on numbers. I cannot do mathematics on this textual data, right? I cannot do mathematics. I cannot say no insulation into glass wool, but I can say 810 into 738 or 810 plus 738, right? So what we need to do is when you are applying this cleaning and transformation process, you need to convert this data into form of numbers. And then you can do, you can supply this to your machine learning models. So you have different kind of data as well. So we have numerical data or quantitative data is any form of measurable data, such as our height, weight, cost of your bills, okay, price of the bike, the rain in millimeters. So all of this will be some, or the balance amount, all of this is numerical data. We also have some categorical data as well. Okay, categorical data. So categorical data is sorted by defining characteristics. This can include gender, social class, ethnicity, hometown, industry, your grades, okay, the color of the bike, the hair of your, the color of your hair, sorry. All of this will be having some sort of categorical value. What do you mean by categorical value? Color of your hair, it could be brown, right? So it could be brown, it could be black, right? So brown, black, and all this thing. Color of your bike, it could be blue, it could be black, it could be maroon, right? Your grades, it could be A, B, C, D, A, B, C, D, E, and so on. So these all are categorical data. We call them as categorical data. You have different categories or different classes. Similarly, cities. So you'll have cities like Chennai, Bangalore, Mumbai, Delhi, So that those are your categorical data. Mobile weather report is calculated by database. No. Weather report is not calculated. Database does not do your calculation. It is databases is used to store the data. Okay, only to store that. Then we have some time series data. So time series data are dependent on time. For your example, your temperature, the stock prices, these all are dependent on time. Okay, so we have time series data, we have textual data. So textual data are just text, text, words, sentences, paragraphs that you see on internet. For example, you want to analyze a Wikipedia document. Okay, so that will be your textual data. You also have audio data. Okay, so currently I'm speaking. This is audio data. So you can also use this audio data to use machine learning project. For example, voice identification, speech recognition, right? Or language translation from one language to the other language in form of audios. Textual data, you can apply chatbots, right? We can have chatbots, we can do your sentiment analysis. You can also do language translation for this textual data, converting one form of, for example, one document which is written in Hindi, you can convert that to English, or one language which is written, one document which is written in German, you can convert that into English, Spanish, and so on. Then you have image data. Okay, so the image data is simply the image or the videos data as well. You have videos. So videos are nothing but these are just the sequences of image, the frames of images, right? So images, if you see, there are different application of this images where you can use this images to apply machine learning. For example, your mobile phones, when you open your mobile phone, you will see that this tracks your face. You will see this square box or rectangle box around your face. So it is identifying the face in that particular image. Similarly, if you open the Google Photos app, so there you will see the segregation of this faces, different faces, right? These images can also be used in medical fields as well to identify the tumors, right? So there are a lot of application and there are different kind of data that you can use for machine learning projects. Okay, right? So that's all for today. From next session, we'll start off with Python for sure. Okay, we'll just get into Python. We'll learn and we'll dive into that. And that's going to be completely hands-on. So that's all for today. Saurav, he will explain you about the course curriculum and all. So let me just check with Saurav and let me ask him to join again. Yes, Lalit will go through SQL, but not in detail. We'll just have an overview how to connect with SQL using Python. Yes, Paras, the classes will be on Saturday and Sunday. All right.
Yeah, hi, Devendra.
Yeah, hi,
So,
Saurabh.
yeah.
Okay.
Yeah, hi.
Okay, folks. So Saurabh is here. If you have any queries regarding the course curriculum and anything, you can ask Saurabh, and he is here to answer your queries. So over to you, Saurabh.
Yeah. Okay. So let me reclaim the host. Okay. So guys, today is the second bootcamp sessions, and this is the full mastering artificial intelligence batch. So first month will be there for the Python. So next Saturday, Sunday, there will be the three hours of class, and every Saturday, Sunday, 3 hours in the morning it will be there for the 1 month of Python, then 1 month for the machine learning. Again, miss 1 month and 1 week. Then we have the miss machine learning plus statistics there. Then we go for the data science also in that, and then we'll start with deep learning. So altogether, 5 courses will get covered: Python, statistics part, machine learning, data science, and deep learning. Okay. So if anyone had joined for the today for the first session, so I will just give the basic introduction about the course and all these things. So let me share my screen. So InsideAIML, which is one of the dedicated platform for the master artificial intelligence, data science, and the machine learning related courses. And one of that, we have the master in artificial intelligence with IBM certification course. So in that course, we are covering from the very basics of the Python till the machine learning, data science, deep learning, and plus the visualization tools like Tableau, Power BI, all these things are there. OpenCV is there. So all these courses are there. So this is the single course, which is the combination of the 9+ together courses. So 475 plus high quality of lectures you will get in this course. 150 plus hours of live course content will be there. 8 months of live class access is there. But course will complete in 6 months only. But you will get the access to the extra some batches. You can join back and all these things, and you will get the recordings of all the Miss Flexi course content plus the live classes. So both the recordings will be there in your My Courses section. So if you log in here, if you go to the My Courses section, I will show you that part. 100% job guarantee is there. We are providing the Ask Tell Us live projects. So you will get the internship opportunity there. You will get the some placements options also there, and lots of other things. But guys, you also have to put some time from your end. Like it's not like if you do not put any efforts and you will directly get the job, it will not going to happen, right? You have to put some efforts. You have to learn the things when you will go to the interview. At that time, at the end, you have to face the interview. But we will guide you how to crack the interview, all these things. But importantly, you have to work on the assignments, whatever we are allocating, whatever the projects we are covering. So all the projects which we are taking, it's real life projects. It's not like just dumb projects or some not used projects in the industry. So all the projects are very important, and all these projects are getting used in the different industries. All the phenomena or all the algorithms which is we are taking, so it is going to use in some of the companies. The important reason behind this is that completing assignments and all this part whatever we have covered is that we are not just a company where we are not just an institute which takes some curriculum and take it. We are a product development company. We have our own product, like Astellas is one of our own products. So if you have seen here, so Astellas is one of the chatbot and CRM and multiple things are there inside that product. So this is InsideAIML's initiative, and we have lots of customers in this. And this whole product, you will get some opportunity to work on this product. You will get some small assignments, projects, and all these things. So that will help you somewhere in future. When you will whatever the work we have, like we have the different clients and you have to train for their specific customer data sets. So you have to do some predictions, you have to do some classification, all these things. So all this work you will get in this project. So it's very big team working there, but people who complete the course at InsideAIML, we give the opportunity to them. So you will get some opportunities, you will get some chance to work on these live projects and all these things. Okay. So that is the advantage of InsideAIML. You will get a chance to work on the Astellas. So we are providing the 6 months of internship certificate and the IBM certification as well. So there are the 9 courses as I explained: Python Heart of AI, Mini Mega projects for Python, Django, statistics for machine learning, Mini Mega project for machine learning, end-to-end data science, and we have the deep learning, Power BI, Tableau, OpenCV. So all these things are there. So out of that, these all are the live classes, means that Python, then the Mini Mega projects, then statistics, machine learning projects, end-to-end data science, deep learning. All these are the live classes. Rest are the flexi content. Means you will get the flexi content for both. Means for Python machine learning, also you will get the flexi content plus the live classes content will be there. So in the Python, as you already know that we are covering from the very basics, that introduction to Python, how to download the software, how to use that, variables, list in Python, then functions, pandas, NumPy, very important libraries inside the Python. Then classes and object, exception handling, web scraping. Web scraping is required if you are working in any company, and if you are working somewhere like you are downloading the data from any website. So if you want to cache, you have to read all the data, whatever is there on this website. So you can use that web scraping like tools and techniques. So that will help you to read the data from the website. So beautiful soup like libraries are there that we can use. How to use that database connectivity in database, everything we have covered inside this database part. Then the modules, packages. Then we have the application development, grammar correction, text, speech to text conversion. Flask is very important. Like whatever the applications we build in the Python machine learning, at the end you have to access that applications through some APIs. So that Flask type of APIs will get covered here. Then we have the mini mega projects. These are the live projects will be different, and these flexi content projects will be different. So you will get the lots of projects. So there is no any lack of project. Django, one of the very important web framework which get used in the lots of companies. So most of the companies are moving towards the Django. They have the it has the lots of good we can say the lots of good features, like you don't have to do lots of coding. If you just create the models, it will create the automatic views and the tables and everything. So that thing you will get. So suppose if I show you here, this is one view of the Django. So you get all the view of your backend. Means you don't have to go and do SQL queries and all these things. So you are getting the access to the backend through the UI. So it is not created by us. It's automatically getting created whenever you are creating your models. When you're doing the migrations, it is automatically creating these views. So it is very important. You can directly create the accounts. Means whatever operations you have to execute on the table, that you can execute it here. Okay. So this advantage is there in the Django, and lots of features are there in the Django. Lots of companies are moving towards the Django. So that Django is near about 35 hours of content we have covered. So that also you will get access. Statistics is there from the very basics of the inference statistics, descriptive statistics, data types, population sample, center tendency, measure of distribution, Z-score, min-max scaling, covariance, correlation. All these topics will get covered. Okay. So these are the very basic and important topics are there. That is there.